Hello, we are Memphis Community University. Today we are talking about the pre-calculus topic, arithmetic sequences and series. So if you watched our last video was just a gentle introduction to sequences and series. And so today what we're going to do is we're going to talk about specific sequence and series, arithmetic sequences and series. We are going to focus on arithmetic sequences for the first half of the video and arithmetic series for the second half of the video, adding up those terms in the sequence. So first off, we need to talk about arithmetic sequence. An arithmetic sequence means that for every sort of adjacent pair of terms in the sequence, remember the sequence is a list of numbers, so every single pair of adjacent terms, the common difference or the difference between those two terms is going to be the same. So for example, you start off with any number you want, say for example 5, and then the sequence is you add the same number every single time to get to the next term. So for example 5, and let's say the common difference is 3, then it'd be 5, 8, 11, 14, and so on. A common example, or the most common example of arithmetic sequence would be even integers. So for even integers, keep in mind that you can start off, for example, at 6, and even integers is you add 2 every time. So the common difference in that case would be 2. And notice 6, 8, 10, 12, 14, 16, 18, 20. Every single pair of adjacent terms in the sequence are separated by 2. If you take one term and you take the next term, that difference between those two things will be 2. And that's what arithmetic sequence is. The difference between pairs of adjacent terms is going to be the same. So what's the formula for the nth term of an arithmetic sequence? We're going to be using this quite often, or basically every single question will use this formula. So it's going to be an equals a1 plus n minus 1 d. So let me just explain what each of these variables are. D is the common difference that we've been talking about. An is you want to find the nth term. And then a1 is the first term. So again, this makes sense because you start off with the first term and you keep adding this common difference to find each next term. So for example, if you want to find the fifth term, well, what you need to do is you want to start off with a1 and then you need to add 4 common differences, because if you add 1 common difference, it'll be the second term, 2 common differences, it'll be the third term, and then so on. So this is why this formula is true. Pretty simple formula. We're just going to quickly apply this for various examples. So we might as well start. If an arithmetic sequence has first term 2 and common difference 5, we want to find the ninth term of the sequence. So again, this common difference is the difference between each of the pairs of terms. So we're going to start off with 2. The next term would be adding 5. That'd be 7. Adding 5 again, that'd be 12. Adding 5 again, that'd be 17. You can keep going to find the ninth term. Just keep adding 5 and you just can list out all the terms. But using this formula, we don't have to list out A1 through A8 to find A9, the ninth term being A9. We can just use this formula right here. And notice it is going to be pretty easy, so let's just use it. So we're finding A9, the ninth term, so we want A9 here. Hopefully you can tell the difference between my A's and my 9's. My handwriting isn't the best. Then it's going to be A1, so it's going to be A1. We can write this plus, because we're trying to find the 9 term, we're going to plug in 9 into the formula, so it's going to be 9 minus 1 times the difference, because we want to add 8 common differences from the first term to get to the ninth term. So what is A1? That's all given. That's going to be 2. What is, or 9 minus 1? That's, of course, 8. And then what's the common difference? That was given. It's going to be 5. So, again, certainly not too hard of a question. 2 plus 8 times 5. 8 times 5, I believe, is 40. So this answer is going to be 42. The answer to the universe. So, again, this formula is not too bad to use. Everything is given. Nice to do. Be able to find the ninth term without having to find the first 8 using this formula. So now we're going to do a similar thing. We're going to find the 12th term of this sequence. -5, -3, -1, 1, and so on. So same thing. We're going to find the 12th term. So it's going to be A12. It's going to be A1 plus 12 minus 1 times D. So 12 minus 1 times D. Why are we using 12? Because we're finding the 12th term. Just keep in mind that in this formula, you don't multiply by the number of term you want. Like you don't multiply by, for example, 12. You need to multiply by 12 minus 1 because you're always starting off from the first term. So in this case, it's pretty easy. A1, while I didn't sort of express it in a sentence, we can easily find what the first term is and what the common difference is. So in this case, A1 is going to be just the first term. You just literally eyeball what the first term is, -5. And then the difference, of course, is the difference between any pair of these numbers, adjacent pairs. So notice that -5 and -3, the difference between that is 2, because -3 minus 5 is -3 minus 5, which is 2. Same thing here. What's the difference between -1 and 1? What's the difference between -3 and -1? It's always 2, because that's what an arithmetic sequence is. There's a common difference between each pair of adjacent terms in the sequence. So in this case, we're going to get 2. And once we located this information, very easy question. All we do is we just plug in where everything needs to go. It's going to be -5 plus, this is going to be 11. D is obviously 2. So it looks like we're going to have 22 minus 5. 22 minus 5 is 17. Let's box that, and we are good to go. So now we have some slightly harder questions. Some of my students are more clever than I am, and they solve these questions in a more faster manner or a more efficient manner. But when I'm doing these questions, basically we're not given the first term or the common difference. We're just given 2 other terms, and we want to find a mysterious third term. What I'm going to do is I'm going to just do the same thing every single time. I'm going to set up a formula, a system of equations actually, whereas we're not actually going to find we're not going to use this sort of thing. We're not using the formula to solve these terms. We're using terms to solve for these terms, as we'll see. Didn't really explain that very well, but hopefully you'll tell as I do these questions what is going on. So basically what I'm going to try to do is I'm going to try to set up a system of equation. One for the second term is equal to -2, and one equation for the sixth term is 10. Using these, but again, I'm not using A1 and D to find the terms. I'm using the terms to find A1 and D, if that makes sense. So in this case, what does the second term being -2 says? Well, that says A2 is equal to A1 plus 2 minus 1. So we can write 2 minus 1 times D. And in this case, we do know what A2 is. A2 is going to be -2. Again, we're plugging in 2 for N. We're going to do the same thing. We're going to set up an equation for the sixth term. So the sixth term is denoted as A6. Instead of A1 plus 2 minus 1, we're going to do 6 minus 1. D is equal to 10. Notice that I'm not even considering the eighth term. Once I find the A1 and the D, once I find the first term and the common difference, I'll be able to find that eighth term using the thing we did above. A8 is equal to A1 plus 8 minus 1D. But for now, we need to first find A1 and D so that we can make this question as easy as the 2 previous questions. So now what we're going to do is we are going to set up solve the system of equations, because notice we do have a system of equations. We have 2 variables, A1 and D, and 2 equations. So all we need to do is we need to solve for these equations. What I'm going to do is I'm going to rewrite these equations to make them a little bit easier to use. I'm actually going to write this bottom one first on the top, as you'll see why, because I think the easiest way to solve these system of equations will always be elimination. So I like my bigger number. This is just sort of a preference. So this is going to be 10 equals A1 plus 5D. Then we have -2 equals A1 plus 1D. All I'm doing is just simplifying 6 minus 1 and 2 minus 1. So then again, we're going to do a system of equations. So you can use elimination if you want. You can use substitution. But again, you always have A1 in these slots. So it's oftentimes, elimination will always work, basically, because you can always get rid of the A1s. So in this case, looks like we're going to have 12, because it's 10 minus 2. Just be careful with your negatives. You're going to have 5D minus 1D. So that's going to be 4D. So what is D? D is going to be 3. Not too shabby, because of course 12 divided by 4 is 3. And then we're going to, just like any system of equations, we're going to plug back into one of these equations to solve for what A1 is. So notice if you have A1 plus 3 is equal to -2, that means that A1 will be -5, because we're going to subtract off 3. So A1 is -5. And now we have made this question as easy as the previous questions, because we have a A1 and we have a D. We have the first term and we have the common difference. So what we're going to do is we're just going to employ the formula that we've been using every single question. And we've already used this formula for these 2 things, but we're also going to use it for the thing we actually want. It's going to be A8 equals the first term, -5, plus the eighth term, so 8 minus 1 times the difference, 3. So it's going to be -5 plus 7 times 3. That's going to be -5 plus 21. I believe that's 16, and we are good to go. So that is going to be our answer. Makes sense. You take the 6th term and you add 3 to find the 7th term. You add 3 to find the 8th term. So that's going to be 16. So again, sort of a pretty involved question compared to the previous question, but we made this harder question as easy as the previous question. Let me just remind you what we did because I didn't really explain it well in the beginning. What we're doing is we're still using the same equation, but we don't know what A1 and D is. So we're setting up the equation to find A1 and D twice. So we know that the 2nd term is -2, so we have this equation right here. We know that the 6th term is 10. We have this term equation right here. Then what you do is use system of equations to find A1 and D. Easiest way, in my opinion, is elimination because always you can eliminate the A1s. Then you're able to solve for your D. You plug in D into any of the equations to find your A1. And then once you have your A1 and D, you don't have to look at this first clause in this sentence. All you have to do is focus on what you actually want to find. In this case, it's A8. A8 being 1st term plus 8 minus 1 times the difference. And again, we were trying to find these to make it easy, like this question. So let's just practice again. Same sort of setup. So we have the 3rd term being 7, the 5th term being 3, and we want to find the 9th term. So in this case, what we're going to do, again, you can take shortcuts if you realize, well, you go from 7 to 3, that's -4 to get to the 5th term. So you would do -4 again to get to the 7th term and then you would do -4 again to get to the 9th term. And that's a way to solve it. But again, I like to do all my questions the same way. I don't really like to think. I'm just going to set up these two system of equations because I know that this always works and I will be able to solve the answer. So in this case, we're going to have two equations just like this. So we're using this 3rd term being 7. So it's going to be 7 equals A3 because it's the 3rd term. And then the formula dictates that we're going to have A1 plus 3 minus 1D. So it's going to be 3 minus 1D. So that's one of my equations. That comes from 3rd term being 7. Now we're doing 5th term is equal to 3. So it's going to be 3 is equal to A5. A1 plus 5 minus 1D. And then we are going to solve the system of equations. I like to simplify, of course, 5 minus 1 and 3 minus 1. So we're going to have 7 equals A1 plus 2D. And then we're going to have 3 equals A1 plus 4D. And then I'm just going to subtract to eliminate the A1s, just like in the previous question. You could use substitution, like solving A1 plus is equal to 7 minus 2D and substituting. But I think this elimination is a little bit easier, but it's still basic algebra. Neither sort of option is very difficult. But in this case, when we're eliminating, we're going to have 4 on this side. We eliminated the A1s, and then we're going to have negative 2D, which means that D is equal to -2. That's perfectly fine. That just means that your common difference is negative, meaning that your terms are just getting smaller by the same amount, -2 in this case. So we're starting off with 7, then it went to 5, and then it went to 3. That's what it means for the difference to be negative. Then what we're going to do is we're going to find the A1 pretty quickly. Let's just plug it into this equation right here. So we can do that on the side. It's going to be 7 equals A1 minus 4. So just be careful always with negatives, of course, because it's -2 times 2. You bring the -4 over, that'll be 11. So A1 is equal to 11. Then we are going to find what we actually want. We want to find the 9th term. So the 9th term is going to be A9 equals the 1st term, just like what the formula says, plus n minus 1, which in this case will be 9 minus 1, 9 minus 1, because it's the 9th term. And then we have the difference, -2. So I'm running out of real estate here, but hopefully you can tell what's going on. It's going to be 11 plus 8 times -2. That's 11 minus 16. That's not too bad. That's -5. So hopefully you can tell that this formula is pretty easy to master. All you need is the 1st term and the common difference. And don't forget about this formula because we are going to use it on the back page. So now what we're going to do, instead of finding the sequence itself, the list of numbers, we are going to add up the numbers in the sequence. So we're going to add up the first 5 terms. We're going to add up the first 10 terms. We're going to add up the first 100 terms. And this, when we're doing this process, like the first page, it has another formula, but the formula also isn't too bad. What it is if you want to add up the first n terms, so this is the nth partial sum. So for example, if you want to add up the first 7 terms, that'd be add 7. What you want to do is you want to take the number of terms that you have, you want to divide it by 2, and then you're going to multiply it by a1 plus a to the n. So a famous math story is that the mathematician Gauss discovered this when he was a schoolboy, and Gauss is like one of the smartest people to ever lived. And basically what happens is, if you want to add up these sequences, like let's say we have like 2, so this is just an example. We have like 2, 5, 8, notice we're adding 3 every time, so it can be 11, 14, 17, and so on. What Gauss noticed is that you take the first term and your last term in the sequence. So for example, that adds up to 19, but then this one also adds up to 19, and then this one also adds up to 19. So instead of adding up all these numbers, you're adding them up in a very particular way. You're adding up the first term with the last term, the second term with the second to last term, the third term with the third to last term, and so on. And why we're doing that is that we're able to use multiplication. So what you're going to do is you're going to just multiply this sum of the first term and the last term, which is this term right here, by the number of terms. But you only want to multiply by the number of terms actually divide by 2, because you don't want to, because you sort of stop in the middle. You don't want to add 2 plus 17 again towards the end. You don't want to add 8 plus 11 again towards the end. So notice in this case, we would only be multiplying it by 3 because you stop in the middle. And this is really why this formula is true. Again, once my students start to use it, they just memorize the formula, just like they memorize the formula here. But hopefully that makes sense why the formula is true. And with these questions, what we're going to do is we are going to find this formula, of course. And what happens is that usually we have a1, and what we don't have is n, or we don't have am. We'll have one of them. So like, for example, we might have a1 and we might have am, but we might not have n. And how we're going to find n is actually this formula right here, because n is in the formula. Same thing with the an. If an is not given and n is given, we're going to use that previous formula that we used in the first video, or the first part of the video, to find that, and then we'll be able to use this formula. So let's see how that works. So for example, in this question right here, we have an arithmetic sequence with first term 2, common difference -3. That's important. Notice that d is again not in this formula, but the common difference will allow us to find either n or an. And what we want to find is we want to find the sum of the first 14 terms of the sequence. So that's going to be S14. So we can just already apply the formula. So because we're adding up the first 14 terms, 14 will go in this slot right here. So it's going to be 14 over 2. We'll simplify that to be 7 eventually. A1 is the first term. So again, this is the first term. Number of terms, maybe we should have labeled this. This is the number of terms that you're adding up. The n. A1 is the first term. And then an is the nth term, of course. So in this case, what is a1? A1 is going to be 2, because 2 is given, the first term of the sequence. Then we need to find an, which is going to be a to the a14. But we don't know a14 because it's not given. So that's what we're saying. To find a14, we're going to use this equation right here. So a14 is equal to a1 plus 14 minus 1 times d. So this is where the difference comes in. It will allow us to find a14. So a14 is going to be 2, because it's the first term, plus 13, 14 minus 1, times -3. So this might get kind of annoying in terms of multiplication, but it's 13 times 3. 13 times 3, I believe, is 39. So it's going to be 2 minus 39, which is -37. And so what's going to be this guy right here? Well, we just found a14. Again, you're always given 2 of these variables. Usually you're given a1, and then you find that third variable using the original formula that we talked about. In this case, a14 is -37, so we plug that in. So the answer is going to be 7 times 2 minus 37. And this is going to be 7 times -35. We might as well just find this number. No shame in doing math on the side here. So 7 times 5 is 35 itself. 7 times 3, that's 21, 24, so it's going to be 245. So this is going to be -245. So keep in mind that it's -245 because the common difference is negative, so all the terms are getting negative. So it makes sense that we're going to be adding up a bunch of negative things, so that's going to be negative. But again, not too bad. we're just using this in formula, and we're actually, while we use this formula, we use this formula to find any variables we don't have. So for this next question, I sort of misprinted it, but hopefully you can tell what's going on. What we're trying to do is we're going to try to find the sum of the first 11 terms of this sequence, 5, 2, -1, -4. Keep in mind that it is a arithmetic sequence because the terms are, the difference between the terms are all the same. It's all -3, which is the same as this one, whatever. But notice it's 5, -3 is this, -3 is this, -3 is this, and so on. So what we're going to do is we're going to find S12 now. So it's going to be S11, not S12, because we want to find the first 11 terms. So S11, it's going to be 11 over 2. And then what's going to happen is we are going to take our first term, because the formula requires your first term. So it's going to be 5 here. And then we are going to add A11. But of course, A11 is not given. We're only given A4. So how do we find A11? Well, we use the original formula, just like we did in this example right here. The formula that we talked about since the very beginning of this video. So A11 is going to be A1 plus 11 minus 1 times D. So it's going to be A1 was the first term. That's 5. That's how I got this thing. I'm just literally looking at the sequence and just seeing what the first term is. Then it's going to be 10. That's always nice. Multiplying by 10 is nice. And the difference, again, is -3 by coincidence because that's the difference between all these terms. 2 minus 5 is -3. This allows us to find the sequence pretty fast. It's going to be 5 minus 30. And 5 minus 30, of course, is -25. So what we're going to do now is that since we use this formula, we are able to find A11. We're going to plug in A11, and then we're going to solve the thing, and we're going to be good to go. So it's going to be 11 over 2, 5 minus 25. So it's going to be -20 over 2. So it's going to be -20 over 2. That's just -10. So it's going to be times -10. So I'm distributing this 1/2 into this thing right here. -10 times 11, not too bad. -10 by just adding a 0. So again, nothing too crazy. We're just using this formula, using the givens, finding the last variable. And this previous two cases, it was this variable that we needed, using this formula right here. What we're going to do in the last two questions is see that we're going to be now using this formula to find the n instead of the an, because the an will be given. So let's see that in action. So in this case, we're trying to find the sum of the even integers from -18 to 36, I believe. So we're going to try to find Sn equals, now I don't know the number of terms. I don't know how many terms are there in between -18 and 36 that are even, but I'll be able to find that using the formula. So for now, I'm just going to leave it as n over 2. And then the first term is -18. And here, I didn't know A14, A11, but I do know whatever A I want, the last term. If you want, you can write this as the last term. Because this is going to be 36. So it's going to be plus 36. So all I need to do is find n. And again, I'm going to use that using the formula. So I know that 36 equals an, which is equal to the formula a1 plus n minus 1d. So this is one of the first questions where we're trying to find n. Usually n has been given throughout. But instead, we are going to use a1, our knowledge of a1, d, and the fact that this nth term, whatever it is, or whatever n is 36. So let's see that in action. It's going to be 36 equals, well, what's the first term here? That's easy. That's -18. We do need to know what the common difference is, so that's going to be plus. And just keep in mind that the common difference isn't explicitly said, but we're dealing with the even integers. So what's the difference between two even integers that are adjacent or that come next to each other? Well, that's going to be 2, of course. 2, 4, 6, 8, 10. Those are all separated by 2. Same thing if we were doing odd integers. If we were just doing integers in general, the difference would be 1, and so on. So in this case, it's going to be times 2. So we just need to solve this equation real quick here. One thing I can do is I can divide everything by 2. That might make the numbers a little bit nicer. So just be careful when you divide by 2. Obviously, everything needs to be divided by 2. So this is going to be -9 plus n minus 1. This 2 goes away because I divided by 2. And then 36 divided by 2 is 18. So it looks like we're going to add this 9 over. So it's going to be 18 minus plus 9. So that's going to be 27. and then it's going to be n minus 1. So it looks like when we add the 1 over it, we'll get our final n, which is going to be 28. And now we are ready to solve this. This is just going to be 28 over 2. Again, we used our last variable. The last variable we needed, we used the original question. So once we found it, we're going to use it automatically, of course. 36 minus 18 is going to be 18 itself. So it looks like we have to do 18 times 14. We might as well solve all of these. We're on the second to last question. So 18 times 14, no shame in doing math on the side. 4 times 8 is 32. 4, 7, 0, 1, 8. Add up these guys. You're going to have 2, 5, 1. 1 plus 1 is 2. So it looks like we have 252. Hopefully I did that math correctly, but if I didn't, the more important thing is just knowing the formula and how to use the formulas. So let's use the formula one last time. We're going to do a very similar thing from this example right here. Let's set up this question. Find the sum of the multiples of 5. What does it mean for multiples of 5? That means that the difference will be 5 instead of 2. And that's basically the only difference in this question besides the first term and the last term. But we're going to use the same method, of course. So we're going to set up the formula. Sn equals n over 2. We don't know what n is because we don't know how many multiples of 5 are in between negative 85 and 60. We'll use the other formula to find that. Then we're going to have negative 85 plus 60 because this is the first term, this is the last term. This is why these questions are different than the previous two questions, because in these, you know what the last term is. And again, we're going to use our equation here, our original equation, our nth term equation, to find how many terms are in between negative 85 and 60. Another way to say that is 60 is the what term in the sequence. Is it the fifth term, the seventh term, whatever. So in this case, we are going to set it up one last time. So hopefully you've mastered this formula by now. It's going to be 60 equals some nth term. We're trying to find what n is. It's going to be the first term, which is negative 85 plus n minus 1. And then the difference is going to be 5. Again, multiples of 5 means the difference is going to be 5. Hopefully you can see that I'm writing on the edge here, but everything is pretty clear. So we need to add 85 first. Adding 85 is not too bad. I believe that's 145. Then it's going to be n minus 1 times 5. Maybe makes sense to divide this by 5. So this is going to be, well, let's just do it on the side. I was going to do some tricks, but why not? Just finish this off strong. It's going to be 7, 14, 0. Sorry, divided by 5, not 2. I don't know why I'm divided by 5, so we're not finishing off strong, but hopefully you can forgive me for this. So 5 goes into 14 2 times. So 2 times 5 is 10. We're going to have 45. This makes a lot more sense. Looks like we're going to get 29. That was too much work for this simple equation. But we got there in the end. We got n is equal to 30. So again, when we use this n equals 30, why do we do all this? So that we can plug in 30 right here. So this is going to be 30 over 2. And then negative 85 plus 60, that is going to be negative 25. So it looks like we're almost done. Just going to be 15 times 25 with a negative. Let's do one math calculation on the side. One last one, and then we are good to go. So 5 times 5 is 25, of course. 5 times 2 is 10, 125. I think I knew that. This is 25. This is going to be 375. Probably knew that without doing this, but definitely no shame in doing math. And we are done with the last question. So hopefully this makes sense. Let me just recount what we did throughout this video, and then we will be done. So we're dealing with arithmetic sequences, and arithmetic sequences are sequences where the difference between the numbers is the same. So there's a formula for this, and what this formula says is that if you want to find the nth term of the sequence, what you do is you take the first term, then you add a number or a multiple of the common differences, and that multiple is going to be n minus 1. So for example, for A9, it was A1 plus 9 minus 1 times D. We did some harder questions where we knew the terms and we were trying to find A1 and D using the system of equation, but they weren't too bad in the end. Then what we did is we found the partial sums of this arithmetic sequence. Keep in mind that this formula only holds for arithmetic sequences, but what it says is that if you want to find the partial sum, meaning adding up the first n terms or so, what you do is you add up the first term and the last term, and then you multiply by the number of terms and divide it by 2. And what we saw is that when we were trying to do this, oftentimes we had these 3 variables two of them were given, one of them being A1, and for example, N could have been given or AN could have been given. In these cases, N was given, and the last two cases, AN were given. But no matter what, you use the original formula, the formula from the first page, the nth term formula, to find that last variable you needed. And again, none of this was too hard in the end. Arithmetic sequences are pretty easy. What I would recommend is just knowing the nth term formula, and then knowing how the nth term formula helps you with the partial sum formula, and knowing that one as well. So hopefully this wasn't too bad of a video. Focus on those two formulas and you should be good to go. Be sure to check out our next video. Our next video is on geometric sequences and series, and there's going to be a similar thing. There's going to be an nth term of a geometric series. There's going to be a partial sum, and there's actually going to be an infinite sum. So be on the lookout for that. Thanks again for watching just like normal, and hope you have a good rest of your day.